All right, I hope I got it right this time. So welcome to the another class for this session. So today we're gonna continue SO3. Okay. So last time, just to recap, the variable usually we use integer, float, and string and boolean. That's probably all you need to know most of the time. And then like when you have variables, usually if it's a variable without the length concept, then it's quite easy to handle. But once you go into something that has length, such as a string, then you do have the concept of how you would select them using the indices. And the things that we went through take some time. It's the how to select something from a list, a collection of things. Like this is a collection of characters, right? And also we went into the collections where we have list, a dictionary, and also tuple. All of this is just containing like a variable that containing more than one items. And again, all of this list, dictionary, and tuple do have the notion of the length. So that means that you can use the same index notation to select the substring or the sub item on the particular variable. And again, the same unintuitive way of doing things that I mentioned last time, it's apply also. Okay, and we will go through all of this in the example that will come for sure, because we use this all the time. Okay, so the next concept is the control structure, because whenever you want to write some logic, this is probably the way to go. Okay, and you probably have run into if loop at some point if you did any small amount of programming language. Okay. So the first thing I want to show you is that I want to have the program that asks for the user number, and this one is just kind of additional thing. So you can have an expression, or this should be called a function. We'll talk about function later on, but you can type input, and you can also do parentheses like this. Okay, so this is you don't really use this one that often, but it's kind of fun to use it. So if I were to execute this line, usually I have to choose the kernel first. Okay, you will see that it's asking for user's input. Let me see this one. The dialog box will appear at the top, and you can also type something in here. You can type something and hit enter. And whatever you're typing in here, it's going to be shown here. So that's kind of a fun thing you can do with small programs that interact with the users. Okay. So what I want the users to do for this particular code is to type in the number. So for example, if I run again, then I want a user select 10, and then it will collect that 10 from the user's input, right? But then the thing is that whatever you typed it in here, it's going to be the data type will be string always. It doesn't really know because keyboard inputs is always string. Okay? So even though I type 10, this is still string. So I want a way to convert this input into number. So I can do maybe integer. That would be something that I want. So I can basically wrap this inside another function called int. Okay. And when I say function, we'll talk about it later. But it's some type of action that you can do. Okay, and this one saying that whatever the user type in here, just convert into integer. Okay. So if I run this code again, actually I forgot the parenthesis. You need the parenthesis too, because this is called activate that action. Okay. So if I do this and I type 10. What you can see is the output. It's going to no longer have that quotation, because that is the number. It's no longer string. Okay. Okay. So that's okay. That's kind of that's the first thing we want, right? And keep in mind that this one is quite fragile, meaning that if you type in something that cannot be converted to number, it will yell at you. For example, if I type like text, then it will yell at you, because you cannot convert that particular text into integer. So typically you need to have some type of a check, and we'll probably won't go into that right now. But assume that the user always going to type in the number. Then what I want to do is I want to keep that input into another variable called num. Okay. You can name it anything, but I'm just keeping to num, okay? So whenever the user type in a number, I can access whatever the user type in as a variable called num, okay? And here I want to have some logic where I want to print out different things based on the value that the user input, okay? So I can do if statement, for example, if, right? It just, I think it reads like English. Num is larger than 0, okay? So just read like a normal English sentence. If num is larger than 0. For Python, this is quite special for Python. You terminate this particular expression with the colon, okay? And whenever I do colon, okay, and I hit enter, you can notice this behavior. The editor will auto indent your cursor, okay? This is not a mistake. This is intentional, okay? Even if I do this, right, and I hit enter again, it will always indent for me. And this is important because whatever you type in here, it has to be indented, meaning that this particular block of code after this will be executed only if the number is larger than 0. Okay, it just reads like English. Okay, so let's see. I'm gonna print positive. Okay, you can do print positive, and you don't even need to limit yourself to one line. You can do one more line, and you can see this behavior too, where if you create a line break, right, the next line is going to be indented at the same amount too. Okay, and that's again intentional, because if I were to print another thing, yes, right, this 2 line, or should I say this block of code will be executed only if the number is larger than 0. Okay, maybe, but I'll just do one line. Okay, it looks nicer. All right, so that's one condition. You can also do another condition where else if, okay, and usually this syntax is, in other program you actually type else if in full, but this one just else if, it depends on the language, okay? And what if the number is less than 0, okay? You can kind of read like that, like what if the number is less than 0? And again, you terminate this particular expression with the colon. And then if you hit enter, then you can see that it's automatically indents again. And again, this, whatever you write after this will be executed only if the number is less than 0. Okay, so I'm going to print negative. Yeah, like that, right? And then, yeah, you can do that too, okay? And typically, you can have multiple else if you have a more complex conditions, right? But for here, it's very easy because it's either larger or less than, right? But then there is actually another condition where it's equal to 0, right? And I mean, you can also do this, else if num equal to 0, okay? And again, you terminate with the colon, and then you can print something like 0, okay? Okay. But writing it this way is actually not the most optimal way to do, because if you already know that, you know, this is the last condition, meaning that it's the rest of the condition, right? You can eliminate, you know, the last line and just do else, because that's actually a better way to do, because this one guarantees that it's going to catch the remaining conditions. So if you need your logics to be able to catch all the conditions, I think else would be another way to do. Was like whatever doesn't satisfy the above logic, just execute this print 0, okay? And now you can verify that this program works correctly by just running it. And then if you type 10, then it will say positive, right? If I run again and do -1, then it will just say, whoop, what? Int input, wait, that's weird. Let me see that again. I didn't expect it to run that long. 10, positive, yeah, that's right, okay. And if I were to run again and then -1, then it will say negative, right? And then if I run again with 0, it would just say 0, okay, something like that, okay. You typically use this one for, you know, like setting up the input, and sometimes you want to make your code, you know, a little bit more flexible. and you can keep like changing some of the parameter, and it kind of do different things based on your setting. The thing that I always use with this is like, you want to save your data or not at the end. And I have like save file. If I save, then it will just write things out into the file and things like that. So very, very common in programming language. Okay. So next up is the loop. Okay, so this one, again, very common, especially when you do machine learning. You're going to loop through your data always. Okay, so let's see how it looks like. Okay. So for example, I want to print a number from 1 to 10. Okay, I can write a print statement 10 times. You know, nobody's going to force me to do that, but that's very, very tedious, right? So let's do looping. Okay, I don't want to write print statement 10 times. So I'm going to do for I in. Okay, so I is going to be called the dummy variable. Somebody call it index. Okay, so typically when you loop, you want something inside the loop to change, or else you are not going to be able to write the logic that keep changing. So the I is the things that keep changing. Okay, and how do you want your index or I to change? So I is going to be in, and whatever come up after this, the concept is called iterable. You know, iterable is an object that can split out things in sequence. Okay, that's the whole concept. If you have things that can split things out in sequence, you can use it to loop over whatever it's going to split out. Okay, the most common thing that people use is called range. Okay, this range is a function. Actually, not function. It's actually the class that's splitting out the iterable that you can specify what sequence you want it to split out. Okay, for example, I want it to split out from 0 to 10. Right? Actually, I want it to be 1 to 10. Right? So 1 to 10. Okay, and you're gonna terminate this statement with the colon. Sorry, not 1 to 10, but comma. Okay. So the range takes in the starting point and the ending point, right? And then you terminate this one with colon. Again, similar to the if statement, if you hit enter, it's going to auto indent for you. And keep in mind that whatever you type in here will get executed. You know, how many times this I got changed. Again, I is going to be it's going to obtain the value according to what the iterable is splitting out each time. Okay, and I think I'm saying too much. I just print it out. Okay, like that. Okay, so and you can imagine that this one is going to get executed on how many times I is going to keep changing. Okay, and I mean if you look at this, then it's it's almost like it should print 1 to 10, right? But if you hit enter, actually that's not what happened. You can try that. Okay, let me just show you this too, right? Okay, it only goes from 1 to 9. Okay, and again, to explain this, it's just a convention, okay? But it works the same way as when you are selecting things. Remember last time when we select the string like A to Z, I was saying that if you select from 0 to 3, right, you are selecting the first item to the fourth item except the last one. I always have the phrase except the last one, right? This one works the same way. So I want to select from 1 to 10 except the last one. So that's why you get 1 to 9. And again, seems very unintuitive, and I totally agree with you. I don't know why, but that's how it works. So whenever I do range, I got a plus 1. So if you want to do 1 to 10, you have to do the range for 1 and 11, okay? Because it doesn't, you accept the last one, okay? Like that. Okay, so just be aware that this one can give you bugs, right? If you were to loop your stuff from 1 to whatever that number, it go to the second to last one, and sometimes you might miss the last row. You know, but actually there are, I mean, if you, I'll talk about it later, but there are many ways to do looping, and this is one of the ways, but I usually don't do like this. I don't usually do range, okay? Because range is, I need to come up with, the number like that, right? But if I already have something that I want to loop, you can use that as an iterable too, okay? So range is very simple way to come up with the iterable, but other things can be iterate too. For example, list. List will give you things to split out in sequence according to whatever it contains, right? So I can do this. Okay, I'm gonna just do, let's comment this out, right? For I in, but now I want list, right? This one, let's say apple, like list of fruits, right? Banana and cherry and things like that, right? Okay, I can also print I, okay? And again, same concept, like whatever, like here, this part is anything that can split out value in sequence, you can loop through it. So if I do this, then you get 3 things inside, okay? So list is iterable, okay? And again, when I do something like this, it's actually nicer because, I don't even have to care. Like, I don't even have to keep track of the index anymore because whatever I got, it's actually the item right away, okay? So this is a better way to do. And, something like this comes up quite a lot when you are trying to like loop through your data. You just get your data, put it in the form that is iterable, and just loop through it like this, okay? Okay, next up, okay, let me show you. Actually, all the collections are iterable, okay? So I can do dictionary, if you still recall. In the dictionary, I can have key and value pairs, right? So I can say name, Tom, right? And then age of 30. I can do that too. Okay, actually this one looks a bit verbose, so let me just do this. Dick, actually let's do person equal, and then name, Tom. So that way it's shorter, okay. And then age is gonna be 30, okay. So this is the dictionary that contains 2 items. Each item has keys and values, okay. So, I just told you that all the collections are iterable. So for I in person, and if I print I, what happened? And what happened here? Why don't I have, what is this? Oh, for I, I forgot I. Okay, so I want you to try first, see what happened if I do this. Does it surprise you or is it not surprising? Okay. Okay, so let me show you what happened if I do this, okay? Notice that what I got is name and age, okay? So again, dictionary is iterable, meaning that it's gonna split one item at a time in sequence, right? So this I will take on something that, it's splitting out, right? So as you can see that it's actually splitting out the key of each item. So that's the key, right? But I got the value, right? There's Tom and 30. So how do I get this thing out? Okay. So there's another, actually, this dictionary. If I dot it like this, you will see that there are some things that I can use. And this one actually ties into the concept of object-oriented programming, meaning that all the variable in Python is actually object. And what I mean as object, meaning that it actually has some action that it can use, okay? And you will be able to do all of this maybe next time, okay? But there's some action that I want from here. It's called key, okay? So let's do this, key, okay? This is an action because, I don't know, not because, but you can see from the color yellow, okay? So VS Code encode function as yellow, okay? So I'm gonna call this action, okay? When you have action, you need to perform that action. So you're gonna do that parenthesis, okay? And if you do it, then you know you have the same thing, right? But this one is more clear what this one is doing, because person.key actually return the iterable for the keys. Okay, so that's why I put it into the for loop. I get the key. Okay, but there's another action that I want actually called value. If I do dot one more time, and I'm going to look for the action called values. Okay, again this is yellow, so it's an action. I need to perform that action, so I'm going to do the parenthesis. Okay, if I run this, I will get Tom and 30. Okay, so there are ways that you can extract the keys and value from dictionary while you are looping. So usually you do dot with certain type of actions, okay? But here's the thing, I want both at the same time. Like how do I get both at the same time? There's actually another action. Let me see. Dot, this one is going to be called item. Okay, if you do dot item, so that's another action that returns the iterable for both keys and value. Okay, I can do this. Okay, and this one kind of interesting because the output is actually not just one variable, right? It's actually a collection. Okay, it's two things at the same time, keys and value. Notice the notation. Parenthesis. Okay, so if you were to recall from last time, the collection that has the parenthesis as the enclosing symbol is called tuple. Okay, again, I think I mentioned to you last time that you don't really create tuple, right? Because tuple has restriction where it cannot be reassigned. But you know, tuple is something that you got out from using something else. For example, if I use iterable item from the dictionary, I got tuple. Okay, that's why I mentioned tuple to you, because a lot of libraries is gonna return tuple to you. I guess that's kind of the convention. Yeah. Again, if I have a collection, tuple collection, then I have a choice to choose whatever item I want inside, right? So I can even do I, and then I want to choose the first item. Sorry, first item is 0, right? I can access the item of each tuple by using the numerics index, okay? And I can even just print I of 1, so that's going to be the second item in the tuple. Okay, so in that way, I can access anything I want, okay? So again, this will come in handy whenever you deal with, you know, storing things in dictionary, and usually the user input, not user, but the parameter input into your model is typically stored as a dictionary. If you need to ever do something like this, then this is how you do it. Okay? Okay. And lastly, you know, anything that has length can be iterated. Okay, so I'm going to do one more time. For I in, how about this? A, B, C, D. Just the normal string. You can even do this too. Works. Okay, so, and now you see anything with length can be iterated. Okay. Okay, so let's move on. Okay, well, you have a chance to do this a lot because this one is the number one go-to, I guess, control structure we'll do in this class. Okay, the last one though, while loop. Okay, so while loop is the looping again, but now this time it will just continue doing that until some condition is false, okay? So let me show you right away the example. So if I say count equal 5, right? And it just read like English. So while count is larger than 5, right? Just read like that, okay? And then we're gonna terminate with the colon. Again, if I hit enter, auto indentation again, okay? Anything that you type after this is gonna be executed as long as count is larger than 5, okay? So we're gonna do print, right? And then, see, if I only do this and I hit enter, then this thing gonna run forever, okay? Because count is always gonna be larger than 5. Sorry, larger or equal, right? Let me just do that, okay? Oh, sorry, actually my code, let's see, sorry, larger than 0. Okay, how about this? Because then this is true, right? So if it's like this, this code's gonna run forever. So I don't wanna hit enter right now because count is always gonna be larger than 0. So this loop will always do, it's called infinite loop, okay? So the way that you would terminate, make the loop, you know, finite, then you have to modify the count value at some point. So I'm gonna do count equal, actually the longer version we count equal count minus 1. So that would be a longer way to do. But a shorter way to do is actually like this, count minus equal 1. Okay. So that would be a shorter way to do. Okay. So people usually do something like this because it's shorter. Okay. But again, if you do this, then every time count is, you know, every time you go through the loop, then the number of the count will be less, right? And once it's less than 0, then the loop will stop. Okay. So what happened is like, you know, I have been doing this for more than 5 years. I never use while loop. Like I don't recall using while loop like at all in my, I guess in my data science related activity. Because when you work with data, then you always gonna know how many times you're gonna loop. Because you always know the size of your data. So I never really come across the need for this while loop at all. Okay, so I'm just gonna leave it here. So you don't need it, probably, okay? But it's there if you need it. Yeah. All right, so next up, let's do function, okay? Because function is make your code much nicer, and a lot of the library they use functions all the time. So let's see what Python function is all about, okay? So function is a way for you to execute a block of code so that when you do it, you don't really have to care about what's inside. You just have to use it, and if you know what it does, yeah, it's always going to do your thing. For example, print. See, print is a function. Print is something that has a block of code inside. You don't really care what it is, right? You just want to print something else. You want to use it, okay? And to use it, then you do this, which is the activate that action. So when I say function, another thing that I like to do is I like to call it like an action. So you want to print something, right? And you know, you just keep it some things inside, and then it's do its thing. All right. Again, you have to choose the kernel. Okay, so let me choose the kernel. Okay. And then yeah, you did that. Done, right? Another thing that you might have used previously would be print len. Len is another function that you don't really care what it does. You don't really care what's the code inside. You just want to use it, right? And len is like if you put some strings in it, it gives you the length of your input. Okay, so that's the example of the function or action, some type of action, right? So print and len is the function or action that is built into Python. So you can imagine that you already have print and len floating in the air. You can use it, okay? But that's not the only thing that Python can do. Python lets you create your own function so that you can define your own action and a block of code that you want to execute, okay? So let's do that. So in order to make your own function, then you can do def, okay? Def is like definition of the function, okay? And give it a name, for example, greet, okay? Followed by the parenthesis, okay? And you're gonna end this with the colon again. And as similar to what we have been through so far, if you do enter, it's gonna auto indent for you. And feel free to write any codes in here. And this code will get executed when this greet action gets run, okay? So I'm just do something simple like print hello world. And that's it. And you can run these blocks of code right now, okay? So notice one thing is that once I run this, I don't see any printout. Like there's no hello world, right? Like this is different from if I were to just do print, right? If I just do print hello world, then yeah, when I run it, then yeah, I see the output, right? But if I just put the print statement inside my function definition, then it doesn't run, right? I don't see any output. So that means this code print hello world doesn't get run yet, okay? But right now, you already have this function floating around in your, I guess, in your list of function, list of available function, okay? So in order to call this one, in order to use it, you have to call the function. That's the formal name. You want to call that function, so you just type the name, greet, followed by the parentheses. That's how you call or activate that function or action, okay? If I run this, then I get hello world, okay? So notice that in order to use function, you gotta define it as if it's your own function, okay? You have to define it, and then you gotta call it to use it, okay? One thing I want you to notice this behavior is that if I go to my terminal, okay, and I think you did this last time, you can inspect your variable in your memory, right? I don't see anything here, okay? I don't know if that's surprising or not, but usually if you do, maybe if you define a variable like a equal 1, right? You will see that a is 1, right? But if you define the function, okay, it doesn't show up in here, and that's normal. So when you define function, it's not variable per se, okay? So the fact that the greet doesn't show up here is normal, okay? But it's there already once you run it, because you can always call it and it works, right? And again, notice this behavior also. I can clear my memory, okay? If you haven't done that, you can try this one, restart, okay? If you restart, that means that you clear all the memories, okay? So let's do that. I'm gonna restart, okay? And it's gonna warn me whether if I do this, we're gonna lose all the variables. So let's try that, okay? I'm gonna restart, okay? Okay, and again, if I restart, then you know everything's gone, right? That's normal. But check this one out. If I skip the first definition, okay, and I come straight down to the function run, it's going to yell at me. It's going to say that, wait, I don't know what greet is, okay? Okay, so keep this behavior in mind. Like even though when you run that definition of your function, it's in here, right? It doesn't show up in your memory. You gotta run this one once so that the program kind of know what is your function definition. So I have to run it, like run it, literally run it, and then I can call this one, okay? So whenever you run into the situation where like you execute a function and it yells at you, you know, like I don't know what this one is. That's the typical cost would be you have to execute that function definition somewhere in your code. If you forgot to run the first block, then it doesn't work, okay? So this is where this button is very useful to me. Like this one, I use it all the time because, you know, when I work on this type of environment, you know, sometimes it's very easy for me to just, you know, I come and run this one and then I forgot to run whatever up there, right? So the run all button is actually my friend because it always runs from top to bottom. So then if I hit run all, I don't need to keep track of where I, you know, like which block I've run, I just run top to bottom. Okay, so this one is my go-to place to run. Like I usually don't do just, like it's quite rare for me to run things from here unless I just wanna, like inspect something in details, usually I just run all. So I design my code so that if I run all, it works, and then I always do it the same way every time, okay? And I guess I get a more predictable result if I do that too. Okay, all right, so the function that print something, it's not that useful. So let's do functions that do calculation, okay? That will be more useful. So I'm going to do def, okay, and this one's called add number, okay. Again, you can print something in here, that's all right. But then now I have some requirement, because if you want to add something, then you might want to say what the numbers you want to add, right? So this function is going to take in the argument. Okay, so another concept for the function is that you can define what the input of that function would be. It's called the argument. Okay, so for example, I want to add two numbers, so I'm going to call this input or arguments a and b. Okay, and once I do this, I have access to a and b, so I can do whatever I want with it. So I can do a plus b. So I want to print the summation of that to input. Okay, so let's try it. Again, you have to run this block or else it won't work, okay? Or another way to do is that I'm just going to call it right here too. So whenever I run it, I always rerun that function definition, okay? Again, if I only do like this, I don't give it any parameter, right? It's going to yell at me now, okay? And I mean, the error message is quite explanatory, right? It's going to say that you are missing two things in here. You're missing a and b, okay? Because when you define it, you say you need to give me two things. But then when you actually use it, you didn't give it anything, okay? So you gotta do what you define, okay? So I'm going to say 1 and 2. And that way, it no longer yells at me. Okay, I got 3, all right? Again, you're not limited to just 2 arguments. You can have A, B, C, and then you can do that too. Okay, so you can have as many arguments as you want, separated by commas. Okay, but keep in mind that once you change this, then you're gonna change whatever you do when you call it. Okay, so like that. Very good. Okay. So far so good, right? But then you know what? Printing things out is not that useful, right? When you do calculations, you might want to get the results back. That will be more useful, okay? So I'm not going to print it out. This is useless. But what I want is actually I want you to return A plus B plus C. It's actually more useful, okay? And right now, if I were to run this, I get the same thing, okay? And the reason that I get the same thing is that in Jupyter Notebook, or this environment specifically, whenever you return something, whenever the last line returns something, it automatically prints it out, okay? But if you were to return something from the function, actually what's more useful is to keep it in another variable. So I can say like my result equal like that. That is actually more useful. You want to keep your results in your variable somewhere, right? And now, if I run this one, you can see that it doesn't print anything out, and that's because this expression doesn't return anything. Like this one is just assignment, so you don't see that print out. But actually, the result is now in your variable, okay? If I view terminal one more time, you're going to see that, and go back to Jupyter, I can see that I have the result. Keep it in my memory, right? So that's something that's more useful. You want to keep your results somewhere so that you can handle it subsequently, right? Or even print it out if you want later, right? So what if I don't return, right? So let's check this one out. If I don't return anything, okay? But then what if I print it out? What do you think would happen to my results? It's actually this code can run without error. So I want you to run and see what the result is. Okay, so I'm gonna run it and I'm gonna show you. So yeah, you can run it and actually it's even printed out. So it looks as if we did it everything correctly. But if I were to inspect my variable pane, then you will see something like this. You'll see that my result is none. Okay, does it surprise you, or is it not surprising? Okay, so right now, if you have a function that doesn't return anything, it's actually returning something, automatically. What it returns is called none. Okay, none. It's actually a type of data. Okay, you can even type none like this. Okay, it's a data type. Okay, if I do type, okay, it's called none type. Okay, it's a data that is empty, but it's actually a valid type. Okay, so your function, if it doesn't return anything, it's actually return none. So your result is going to capture that none data. So your result is empty. So that's what happened. Okay, so keep in mind that you can set your variable to be empty by set it to be none. Okay, and that is a valid choice in many situations. Maybe you wanna start your variable as empty, you set it to none, something like that. And you can even check if your variable is none or not. And then quite useful trick, pattern to adopt later on if you want. Okay, but I'm gonna keep it like this because this is more useful. Okay. Next up, it's going to be about writing the function in a more maintainable way and in a more, I guess, conventional or a good practice way. Okay, so I'm going to have another function called describe pet. Okay, and in here I'm going to say pet name and also pet type. Okay, so again, I want two things in here. Okay, and inside here, I'm just going to print it out. Okay, so first of all, this is maybe a good chance for me to showcase the F string. But first, I want to do the normal way. So I have a, right? I want to write a sentence to say I have a pet name, right? So I need to do some string summation. I have a pet name, a pet type, right? Plus name, and then plus pet name, and then plus, and then dot. Okay, and the reason that I have to do such a complicated way is that I want to have a sentence that has dynamic data, right? It can change the pet type and name according to what user input. But then when you write in English, you gotta have space between words. So when you do the string combination, you gotta take care of that space. So that's why I do have extra space, in here, and then also in here, okay, and in here, because I need that space. Okay. Okay. So if I were to run this, right, describe pet, then I should say my pet name is Tim. This is not a pet name, but it's a dog, right? And yeah, I have a dog named Tim, right? So if you don't include the space, extra space, then your sentence will not be spaced correctly, right? Okay, and let me do a little bit of sideway because this one I also used it quite often. So there are many situations where I just want to write things out like this, right? But then writing like this is pretty tedious and very kind of, it takes a lot of my time to do this, right? So I want to do it in a much better way. It's called F string. Okay, so check this one out. So again, I want to print, right? So let's see. Usually the way that I want to show you is that I want to see if I can write the whole sentence first. So I have a dog called Tim, right? So this is what I want the sentence to be. So just type the whole thing in, right? But I want this dog and Tim to be name, right? Not called name, right? To be dynamically generated, right? So I can do F in front. And this is why it's called F string, because there's a letter F in front, right? Once you put F in front, you give this one a superpower, okay? So you can come in here and wait, this one is something that I want to change dynamically. So I'm going to delete it, put the curly braces in state, and I just type the actual variable. So it's going to be pet type. Okay. And again, you know what, Tim is also the things that needs to be dynamically inserted, right? So I'm going to delete it and then put the curly braces in that place, and then I'm going to use pet name. Okay. And as you can see that it's going to do the same thing, exactly the same thing as the one above, you know, but the way that you write F string is much more natural, because you don't need to, you know, worry about, you know, did I add extra space in front of, you know, whatever the things that I want to sum, right? It's much more natural. But again, yeah, it takes more getting used to in the beginning. But I use this all the time, like, because it's much nicer to work with, right? Rather than the string combination. Okay. All right, but this is not function, right? This is just a way to construct the string in a more efficient way, right? But here's the thing. If I were to forget the order of my argument, so maybe I say dog and Tim, right? Then this is a valid statement, right? It's going to do its thing, but now it's backward, right? So this is one of the things that if you have function with a lot of arguments, then you're going to have to remember the order of your argument, which is kind of, you know, it doesn't make sense. You know, if you have like 10 arguments, then nobody's going to remember the order, right? So a better way for you when you call this type of function is actually to use what's called the keyword argument. So I can always say that this dog is going to be used for my pet type equal. Okay? And if I do this, then the order doesn't matter. Okay? My pet type is always going to be dog. Okay? No matter the order. Okay? Again, this one is going to be pet name equal. Okay, so, and now if I run this one, it's going to be correct no matter what. And this is kind of like the way that I would recommend you use your function. Okay, and especially the function that you import from other library. Usually they have like, you know, at least 5 or 6 arguments. You're not going to be remembering the order, right? And using this type of function argument, keyword arguments during your function call is extremely useful, and save you from future bugs that you might come across. Okay, very easy to make mistake in your function where you switch the order, and then maybe it doesn't give you error, but it do the different logics. That's even more alarming, right? So highly recommend something like this. Okay, and keep in mind that if you use this type of keyword argument, then the name has to match, right? So this pet name, pet type, and this pet type has to be the same. This pet name and this pet name has to be the same. Okay, if you ever change this, okay, then you gotta come back and change here. Okay, so something like that. Okay, so keep in mind that you gotta make sure that you know your function definition when you want to use your keyword argument. Okay, and typically Python is or not Python but VS Code has some helper. If you put your mouse on your function, you're gonna see that it already tells me what I should use, right? There are 2 things in here. So I mean, there's no reason not to use it, because you can always just inspect it by just putting your mouse over your function, right? So you can try this with other functions too, right? If you do print, right? Check this out. Yeah, here, see? If you want your print, use your print, you can also use your keyword arguments too, right? So, but now it's a bit more complex because print and can actually accept the dynamic length of the arguments. But see, there's something else I can use. It's called sep. You see one sep, right? Okay, so let me show you this one. If I do like A, B, C, right? So, and it prints A, B, C. Like, notice that between the A and B is a space. Ever wonder how we could change this? Of course, I just told you, right? Sep. So I can do this. Sep equal, comma. And there you go. That's how you do. Okay, so print is actually a little bit more complex because print, whatever this is dynamic length. So you can give it any order of things, how many things, that doesn't really care. But if you want to kind of, customize whatever the separator is, then you use separator. And you can even customize how the sentence will end, right? I can do end equal, okay. And then, I don't know, E. Yeah, it would just put E in here, which is, I don't know why. But maybe something that makes more sense would be like comma or semicolon. Yeah, I would just do semicolon, right? So a good way to learn, give you more in-depth information is just to put your mouse over the function and see, what else you can do. Okay. This one, I digress. Okay. One more thing is, what happened if I do this? Describe pet, okay? And now I just do pet type equal, or pet name equal Tim, okay? Basically, I just keep this function just one thing only, right? What happened here? It's yell at me, And then the error is pretty self-explanatory, right? So like, I'm missing one thing in here, pet type, right? I haven't given it the type yet, okay? And there are many situations where, when you design your function, you might have 10 arguments, right? But then you only want user to specify a couple ones, right? And then the rest is leave it as the default value. And I can do that too, because maybe, most people own dogs. So if they only give me, the name, then I would assume that they're talking about their dog, right? And I can do that by saying that my pet type is going to go to dog. And notice that this keyword argument, the specification of this is done on the function definition. This is not where I call it different things. So I'm just saying that if nobody gives me what the pet type is, I'm going to default to dog. Okay. If I do this, then now my function works. Okay. And this pattern, like this, how you, the way that you would define function with the default value is extremely useful, okay? Especially if you have a lot of arguments. And this is how they did it. They do it all the time in the library, okay? In each library, they'll have the function that has 10, like even more than that. But then most of them will have the default values. And you only need to specify a couple things and you're good to go. Okay, you don't need to specify everything, and that's good. And there's nothing to prevent me from overriding this, right? If my Tim is not a dog, it's a cat, then I can say pet type equal cat, right? I have an option to override that default value. So I can do that, and then I can say my cat. So, there is no downside to specifying the default value on your argument. So I do recommend you putting your default value if you can. There's no downside, I don't think, except that it just looks long, right? But it makes your code more robust in the future for future use. Okay, And next, we come to the some exercise for you to think about, okay? So right now, this exercise gives you data to work with, okay? So this data is called students, okay? And notice that this one looks a bit complicated, but let's break it down a little bit. So first, I can collapse all of this. And you can see that this one is just a list, right? When you have list, then you have the square brackets, okay? Okay, now, the list, you have many items. So each item is a tuple, right? Because you can take a notice at the parenthesis. So the parenthesis enclosing the collection called tuple, okay? So in each item, you have a tuple, right? And the items are, just index name, right? But then the third item of each tuple is actually another collection. This is dictionary, right? The curly braces is the dictionary with 3 items inside, right? Which is the score for each class. So right now you have the nested structure. Basically, you have the list inside it. There's a tuple. Inside it, there's a dictionary, right? So this is a good way for you to kind of get your hand dirty on how you manipulate the data type. Okay. So the instruction is I want you to first write a function called the average grade, right? This function will take in the student tuple. Okay, the student tuple meaning that it's the item inside the list. Okay, and this function will print out or return the average grade across all subjects. Meaning that if I give this function the first student, it should give me the average of 85, 78, and 92. Okay, it should give me the average of these 3 classes. Okay, so first I want you to try to attempt to do this problem first. Okay, and I will show you how I approach it. Okay, the only condition is you should not use AI at this time. Okay, you can use AI later. Okay, it will give you the best answer, but it's outsourced your thinking too much. So I want you to attempt to try to solve this problem, because what I want you to notice is actually how would you start. The starting point is the most important thing, okay? And usually this thing comes with experience, okay? AI is going to skip all of that, which is, I don't like it. I want you to try to figure out how would you start first, okay? And I'll give you maybe a 15 minutes break too. So feel free to take some rest, come back, work on it, and I'll show you how would I get started, okay? All right, so after I walk through some of your great works, okay, I noticed, and this is quite normal, okay? So whenever you see an expression like, okay, let's make a function, everybody's gonna do this, def average grade student, right? And then I think that's what happened to most people, is that you don't know how to go next, right? But this is the wrong starting point. If you start like this, I think you are making your life much more difficult than it should be, okay? The way that you would do is actually try to break it down into the most simpler ways you can do. So normally you try to do it without function first. Function is an abstraction. You don't want to abstract anything. Right now you need to be as explicit as possible. So let's do this. So I'm going to take out the function. I don't want to work with function. I just want to see the steps first. And then once I do this, I can wrap my stuff with function. I think that's a better way. And I do this all the time. I don't start with function. Okay, so first I want to see, okay, this function is going to take a student tuple. Okay, so right now we have student tuple. We have a lot of student tuple, right? Why don't we just start with this one? All right, so I'm going to take the first guy. Yeah, this one. Okay. I'm going to just write it down like this. So I have student equal that. So see, I don't start with function. I start with the most basic thing that I can have, which is, wait, I have this data. Okay, I can even print it out too if I want, right? Student, right? So anything that can get you started, I think that's a better way. Okay, like this. Okay, so yeah, right. So what else? What else do I need to do once I got this variable, right? I want to calculate the average grade. Okay. So next stop is how do you calculate the average grades of all the students? Can you attempt one more time with me? So can you start with this? And can you calculate the average grade for me? I'll give you a couple minutes. Approaches, right? So again, the simplest thing you can do is just hard code everything, even like this. This is and now you know that you want this answer, right? But now you can kind of work backward because you don't want to hard code 85, right? So you work backward by saying that how do I get 85? How do I get 78? How do I get 92? Sorry, has divided by 3, right? That's how you do average, right? So how do I get this number from the data above? So maybe you can break down the problem where if I print whatever stuff's inside, I want to get 85. So that this is the way that I can access that value. Like how do I print just 85? That's the next problem that you might want to do. Okay, I'll give you one more minute. Okay, so break down the problem. So right now the problem is, can you print 85 for me? And what I mean by 85 is actually that 85 above, no, not the, maybe 78. So how do you print 78 basically, right? How do you print 92? So I mean, if you can print this 3 number, right? I want to print 3 things in here, right? And I want to get 85. I want to get 78. I want to get 92. If I can do that, then I'm on the right track, right? Okay, like that. Yeah. So that will be the next problem.
Excuse me. How do you put multiple lines into commands?
Oh, I just hit enter. Mhm.
Just enter.
Something like this, okay? Say I want to print 85, okay, that's my first job, right? So maybe I can start from the student, okay? So if I print student, what happened? Yeah, it's a whole thing, right? How do I drill down into that 85? So, this is tuple, so I need to access the item. Okay, if I want to access the item, I need to do the index notation. So 0 meaning the first item. Nope, this is not 85. Maybe 1. No, definitely not. Maybe 2. Wait, I think we're on the right track. Right? I see 85, but there's something else. I don't want something else. I just want 85, right? This is the dictionary. Okay, it's again another collection where I can access the items inside, but I don't use the index notation anymore. I use the key. The key will give me the value. Okay, so let's try one of the key. Okay, so here I can add in another selector. Okay, so let's say key is, and VS Code is even smart enough to me to show me that this is what I can use. Just even better, right? Let's choose English. Oh, 78. No, that's not what I want, right? I want math, probably math. And there you go. I got 85, right? Once I got 85, then the rest should be pretty easy because I can just keep changing my key be English, right? And I can do science. See, this is what I do all the time. Like even now, like when I work on the new code, I always do something like this. I always like, okay, how do I start from the very basic things like this? Just print it out, type, hard code everything, right? Now I got 3 numbers. Okay, so now my next step would be, I want to find the average of all of this number, right? So why not just hard code like this? Student, right? Plus that, plus that, right? The whole thing, you're gonna sum together, divided by 3. That's it. That's how you have to do. So, okay, it's a bit long, so I'm gonna put it as the average or something like. Just put into another variable, average grade, so that it's not too long. But I can just print average grade now. There you go. I got 85. Okay. Okay, and then once we got this, then we just have to think about the next step, which is how do I put it to a function, right? Because function is usually the last thing that I do. It's an abstraction. We don't want this time is more explicit, right? But now it's time for abstracting all of this into a function. Okay, so again, this one takes some experience, but you can kind of notice how I go about solving this problem, right? So I noticed that if I were to write function, that means that I have to have some input to the function. And right away you can see that if I were to execute this logic, I need this as an input. Like I need the student tuple as the input, right? And so yeah, why don't we just give them the input as a function? So def, average grade. Okay. Okay, and this one you have to do this indent now because it's inside the function, right? One more thing to just want to make sure, because you cannot have the same thing. This is going to be problematic. So if you have the function name and stuff inside, it's okay for now, but let's make it different so that it doesn't cause any confusion later. So I'm just saying results, okay? But now the functions, I have the liberty to give this function an argument, and that argument is just a student. Okay, and that's all I need to do. So if I want to return, I just return it. Okay, and again you can see that this one looks much different from the answer from my AI, because this is something that I would do, and I would be more happy if you give me like this rather than the polished solution from AI. Okay, because I know that's not the beginner is gonna write. The beginner is gonna write something like this, not my solution. Okay. So I didn't give you a lot of examples, but I want you to actually spend time working on it, figure out how to get started. I think that's more beneficial to your career, not just Python, but anything. Break it down into smaller steps. Okay, so I think we still have one more instruction. So the instruction said that print all the average grades. Okay, so this one, it's kind of follow. Once you have the function, you have that ability to get the average grades, right? So the next is to just kind of print it out, right? So print it out meaning that you can loop through your students. And as I mentioned, the students with the F is a list, and the list can be an iterator. So you can loop through that list, right? So, and again, I don't usually just write things right away. I just try to think about, okay, how do I loop first? Okay, so usually I just do like for I in students. Okay, and usually I just print it out, like see, okay, so what do I have here? Okay, if I print it out, then yeah, I have all the students tuple, right? And it just happened that my function takes in that tuple. So this is quite easy now because I can just call my function average grade, okay, and then I just take in the tuple, okay. Again, my function is returning something, so maybe I can just do a equal, and I can just print a, okay, and now I got all the grades, okay. So something along this line, okay. All right, so feel free to work through some other problems. Okay, I will come back to this again once we learn about Panda, because I want to showcase that actually all of this is kind of like a data manipulations, and usually there's a library that makes your life much easier. It's called Panda. So all of this is like a basic data science stuff. So if you use Python, it's okay, but it's not as convenient. That will be a much more convenient way to do. Okay, so feel free to try on your own, look through the solutions and things like that. But you're gonna see that all of this takes about, I don't know, 5 to 6 lines at least for all of this. But if you use Panda, it's like super easy. I guess super easy once you understand what the library is doing, but all the operation in all of this is actually super easy. Usually just one line of code and you're done. Okay, so I will save this for later. Okay, but now I would like to move on to talk to you about the two, I guess, stable cornerstone library in Python, which is NumPy and Panda. And this one is super useful if you are going to work with data. Okay. So first of all, NumPy, right? Okay, to motivate the use of NumPy, I can give you this example. Okay, so well, first I need to import the library. Okay, so I will talk about this later once we talk about the class, but NumPy is like a package. Okay, so right now your Python doesn't know about NumPy yet, so you gotta import it. So import NumPy as, okay. So normally if you do this, this is sufficient. But if you only do this, then you have to refer to this library as NumPy. Like all the time, you have to type NumPy, literally NumPy. So people find this one too long, so they're gonna make an alias called NP. So as NP, just use an alias, okay? All right, so just want to show you, when you import something, where is it? Okay, if you ever wonder, let me show you. Okay, so if you recall that we install our Python in the home folder. So let me go to my home folder. Here, users, admin, and then if you recall, I have this folder called .vnv. The one that I have you verify that did you have this one or not? If you don't have this one, then you need to install it, right? So this one contains everything that you import actually. So I'm gonna go in here, okay? And there's the folder called lib. So that's the library, okay, that you install. Okay, you don't have to do this, right? Just watch me. I just want to show you that this is where the stuff that you import located, okay? That's called the folder called site packages. Okay, so I'm just going to here, okay, and in here there's a lot of, so all of this, like all of these folders are actually the library that you install through the commands that you did last time. The long command is called uv pip install. It's actually install a lot of the packages, including the dependency. So one package might need more packages, and then it keeps installing all of those. So that's why I had you install maybe 10 or 10 to 12 packages, but what you end up with is like, I don't know, like 300 packages in the end. So that's normal, okay? I just import NumPy. So where's NumPy? Right here. this is where that import numpy is. It's actually import from this folder. If you ever wonder, like, what is numpy? Like, can I look at the code? Yes, you can. Just go inside, right? And usually, you don't have to do this, okay? But I'm gonna open my VS Code one more time, and then I'm gonna drag this numpy into my VS Code just to show you. This. So these are the source codes for that library, and when you import things, it's actually come from the init right here, this file. Okay, so this is the starting point for that import. Okay, and there's stuff in here, like all of this. This is the source code. So actually NumPy is written in Python. So yeah, so you would expect that this is a Python code in here, something like that. You'll get used to this more once we talk about class and things like that next time. But I just want you to know that these are all where it is. Okay. Yeah. I digress again. All right. So you got NumPy. So what can you use with it? Okay. So first, I want to motivate the problem where if you, I guess this is kind of extra. If you have a list, okay, let's say my list, right? You don't have to type this, I'll just do it quickly, okay? 1, 2, 3, 4, 5, okay? And let's say I want to find the summation of all the things in this list. How would I do, right? So first of all, I don't have any, I have to code it myself. I can do maybe for my I in my list, okay? And then let's say first I want to print it out, right? Okay, and then I need to run this. Actually, you need to run this one too, so don't forget to run it, okay? But anyhow, I got this 1, 2, 3, 4, 5, right? So I say sum, num sum, okay, equals 0. And whenever I go through my list, I want to say num sum equal num sum. I don't want to use sum because sum is actually another function in Python. So plus I, okay? And then maybe I can print num sum. Okay, so I get 15. So this is how much code I need to do if I want to do the summation of the things in my list. Okay, using Python regular collections. But I mean, in a scientific calculation, you know, summing things in the list or vector is pretty common. So maybe I should have NumPy, right? So what I can do, instead of all of this, I can just do one line. np.sum my list. Oh, sum, not num sum. Oh, I guess my list is gone. I need to do this. There you go, done. So this is the essence of NumPy, meaning that if you import NumPy, then you got superpower in terms of scientific calculations. Anything that people usually need when you do calculations, like summation, or other things like I want to see my max, right? Max of my list. Okay, you got it, something like that, right? And you might, you know, min my list, right? So a lot of things that you want in your calculation toolbox is already there, like all the methods that you can use, pretty convenient. So NumPy is used throughout Python, and then it's an underlying package for a lot, like, I guess I would say like 90% of all the calculation packages that needs calculation will use NumPy. Okay, so you don't directly interact with NumPy per se, but you kind of use it indirectly throughout, you know, like for example, you use machine learning behind the scenes in NumPy, okay? Okay, so that's it. You don't need to type this, okay? I'm gonna go through this one more slowly, okay? But again, so this is one way to do, right? But I wanna go through a more formal example. For example, I wanna create a list first, so I would say, so if I say my list equal to this one, okay, and I hit enter, okay. If I look into my terminal again, you'll see that I have, let me just restart one more time. I want to clear everything. Okay, and I just need to re-import NumPy and then this, okay. So you will see that I have my list, which is a list, right? This is a Python list. So again, this list doesn't have any way to do summation. yet, right? So I want to maybe supercharge this list to become, more powerful. I can do that with NumPy. I can say np.array and then my list. Okay, and this one, if I put it to np list or something like that, right? You can see that now I have a new variable, right? This one again contain the same information, but then the type is different. This one is nd array. Okay, so this is a n-dimensional array. So NumPy treat your list as vector. So you can have, like vector, matrices, and then if you have higher dimension, it's called tensor. So now it's more like your mathematic stuff now. So and then it's very, very easy to do like vector calculations, metric multiplication, and things like that, which you need for scientific calculations anyway. So using Python list is very, very cumbersome. Okay, so my list, once you do this, okay, my list is superpower. You know what? I can do this, dot. And now you have tons and tons and tons and tons of methods that I can use. A method meaning action, okay? And wait, I want to sum everything in my list, right? That should be called a method for that, right? Let's search for it. There you go, called sum. See? I got the method called sum, so I call my list.sum. And then again, this one is the action, so I need to do that. And there you go, I got 15. Okay, so you would not be able to do dot sum if you don't convert your list into NumPy array, which is nd array. Okay, so normally, you don't do this manually. Usually, this is something that you typically get from the library, like when you do machine learning, things like that. Usually, you get NumPy array as an output, and you can do some sort of calculation with it. Okay, again, you can do pretty much the same thing that I do, which is np list, right? Let's say you want to have an average, you can do mean. There you go, it's 3, right? np list dot max. I want to see the max, right? 5, right? That's the same thing that I just showed you, right? There's even the method called argmax. Where is the max value? It's at the index 4, which is the last location. So there's many things that help you make your code much more concise by using all this method. Okay. And right away, you're gonna see that when you use NumPy, there are 2 ways of doing. Okay. So you can have the same thing, but there are 2 ways of doing. Okay. Which is you can write np.sum and you do np list. Or you can do np list dot sum. Okay. Both of them will give you the same answer. It's just a different way of doing things. So the first way is to use the package itself. So in the package itself, which is np, there's already a method that you can use or actions you can use. So you can use that. Or inside that particular object or variable, there's also a method that you can also use. So you probably gonna see both ways. So there are people write both. So just want to let you know now that if you see something like this, that's just kind of like a stylistic way of doing things. Okay. Okay. So let's do some of the simple operations for NumPy. Okay. So first, this is another thing that I usually, if you use Python, take some amount of line. I want to create an array from 1 to 100. Like how would I do? Again, in Python, you would do something like this. My list equal empty, and for I in range, right, 1 to 101, I want to do my list dot append I. Yeah. So if I print it out, wait. Nope. I have to print my list. Wait, this is misspelled. My list. Okay, so yeah, so this is how much code I have to do in order to get 1 to 100. And keep in mind that I have to do from 101 because the last item is removed, right? So yeah, this is kind of cumbersome. I want to do something much better. So let's do NP. Again, I wanna comment this out, right? I want to do NP dot A range from 0 to 101, and there you go, one line. So this is typically happen if you try to do something with Python. It's gonna take a couple more lines rather than just one line. Okay. Another thing that maybe I just throw it around, right? Another thing that I really like is random number. Oh, maybe yes. Do I have it? No, I don't have it. Okay. So another thing that I always do is generate some random number just for like input and stuff. And you can do that pretty easily with NumPy. So I'm gonna do np.random. Okay. That has to be too random. Okay. So I can do 100. There you go. I get 100 numbers. Something like that. So it makes my life much easier. Like in Python, I have to do looping and then come up with random numbers, put it inside the array. This one, usually just one line. So that's kind of the theme here. Like even if I go to another library, Panda, you're gonna see that it makes your operation, contained into one line, basically, for all the things that you need to do. Okay, I think I need to start using the same type of variable as this is my solution. So I'm gonna say array equal, okay, just make sure, right? So in my cheat sheet, I had the array called ARR, okay, so I'm gonna put it as the np.a range, okay, 1, 2. So this one is gonna be a number from 0 to 1. Actually 0, I want 1 to 100, not 0. Okay. Again, if you ever want to see what this one is all about, you can also put your mouse on it, right? And now, did you see something like this? Now you can start to customize your input, right? I want to say start equal, stop equal, right? See, when I write it like this, then when people read it, it's actually make more sense, right? And I can also have step equal to, and right away I got the list that has the number increment by 2. Okay. All right, so let's inspect this variable a little bit more. Okay, so this one is saying that print the shape. Okay, so in NumPy, keep in mind that this is more like vector, matrices, and tensor, and things like that. So the ability to know the shape is quite important, as well as the dimension. So if you ever want to inspect that shape and dimension, then you can do ARR, which is the name of your variable, dot shape. Okay, so dot shape, it's the data that comes in with that particular object. Okay, I might go too fast, but if I do dot and I go through the things that I can look at, then you'll see something called shape should be in here. It has to be the methods. Where's the method called shape? I don't think it's here. It should be up here. Here, right here. Actually, I forgot, it's on the second line. So I can do dot shape, okay? And then once again, I got something like this, okay? So what you see here, okay, this is again a tuple, okay? Meaning that it has the parenthesis, right? It's a tuple, again. It's gonna show you, how many dimensions you have. In here, this is the tuple with one item. So you only have one dimensional array. Okay, this is one item, one dimensional array. And the number, I would say the number of item in that dimension is 50. Okay, so essentially this is a vector with 50 things in it. So vector with 50 bases, if you want to think about the vector math. So vector with 50 basis vector, okay? Okay, so let's do something like this, 2 by 2, the matrix is pretty common. Okay, so let's do ARR to x2, 2 by 2, okay? Equal np dot array. So this one is going to be a little bit more involved. So I'm going to do a list inside, right? And inside this list, I'm going to do 1 and 2, okay? Separated by another list, 3 and 4. Okay, so I know the syntax is a bit crazy, but keep in mind that we have the list inside the list, okay? It's almost like 2 rows, okay? If I were to print it out, then I think it will be more clear, okay? See that? So this is a 2 by 2 matrix, okay? Okay, and if I want to inspect, right, in the future, I might want to inspect the shape of this variable. I can do print arr 2 by 2 dot shape, okay? And again, this one is 2 by 2, so I expect my shape, right, to have 2 dimensions. So the fact that you have 2 things inside this tuple, meaning that you have 2 dimensions. And in each dimension, there are 2 items, okay? If I want to make it more clear, then I might want to do this. So I want to add in more things in here. 1, 2, 3, 3, 4, 5. And right now, if I do this, then you're going to have 2 by 3 matrix, right? 2 rows and 3 columns. And as you can see that the shape is 2 by 3. Okay, so that's what it is. So this is a 2-dimensional array with the each dimension has 2 and 3 items. Okay, 2 by 3 matrix. And then there's nothing to prevent you from making this into a higher dimension, although it will be quite hard to visualize this one now. Okay. Okay. So let's move a little bit further. So again, I want to show you that if you want to do, like basic operations on the array, then you can. This one, I want to sum all the elements in the 2 by 2 array. So let me go back to 2 by 2 again. Make sure it's the same as the solution. Okay. So 2 by 2 array. I want to sum everything. So ARR 2 by 2. Okay. Dot sum. Okay. And there you go. I got the summation of all the full number inside. Okay. And when you have a higher dimensional array, then you do have option if you want to sum along the row and sum along the column. So that can be particularly useful. So I can do sum, but now I say axis equal. Okay. Again, if you where does this come from? Just look at the. I just look at the function definition. There's like axis. So axis tells you where to sum along. Okay. So if you say 0, then it's gonna sum along the first dimension, which if you visualize it, it's along the row. Okay. So if you sum along the row, then it should be like this. That way. That's calling summing along the row. Okay, like that. So you should get 3 by 7, if I'm not mistaken. 3 wet. So actually I'm mistaken. I get it the other way. So it's actually that way. Okay, it's 4 by 6. Okay, yeah. I always get this one wrong. So sum by the first dimension, so sum along the row. And again, if you do this, x is equal to 1, it's a sum along the column. It's actually the other way. Okay, so yeah, I always get this wrong. Apologize for that. But this is something that if I have to do it, then I will construct a simple array like this and test it myself, so that I can make sure that I do it correctly. Okay? So, but that's how you would do it. Okay. Again, you can do mean, which is the average, right? So we can do ARR 2 by 2 dot mean, and again that will be the mean of all the values, so 4 values. Okay. Or you can have, again, in the mean function, you can have axis, right? So yeah, let's play around with the axis. So axis equals 0. Then that's going to be the mean along the row, so which is actually, I guess, yeah, and 1. something like that. Okay, so you do have some options to do something like this. And again, another thing that I use quite often is to change the shape of it. So you can do array 2 by 2, right? But then I can do reshape. Okay, so this one comes up quite often once you have to deal with a lot higher dimensional array and you want to do some matrix multiplication, things like that. Sometimes you need the shape to be a certain value. So I can reshape it into 1 by 4. Okay, and you can see that this one will have 1 by 4. Okay, so which is 1 row and 4 columns. Okay, it's still the 2-dimensional array though. If I, let's say I can do this, new array equal, right? If I were to print this out, new array. Okay, and then I want to print the new array dot shape. So I want to see the shape too. Okay, so if I reshape to be 1 by 4, of course I will get the 1 by 4 shape. Okay, but keep in mind that if you have the shape that has 2 items like this, that means that you have 2-dimensional array. Okay, which is different from if you want to do 4. It's actually different. Okay, so even though the number or the data is the same, okay, but this one is the 1-dimensional array. This is the vector with 4 things in it. But if you do 1 by 4, this is a matrix that has 1 row. Okay, you can even do this 1, 1, 4. This is actually the higher dimensional tensor, which is, I don't know, 1, 1, and then 4 on the last dimension. So you can imagine that you can keep adding more dimension into it, and it certainly can do that, right? Even though you still have the same data, you can make the matrix, or you can make your data into a higher dimensional tensor. And you might be wondering, like, why do we even want to do this? And it just happened that in your deep learning, you typically deal with a higher dimensional tensor anyway. And sometimes you have like one constant. Do you want to add into that? Let's say you have like a 6-dimensional tensor. You want to add a constant into it. Sometimes you might want to convert your constant into the same number of dimensions before you do some operations. So that's particularly come useful. But we don't use NumPy per se. We're going to use another library called PyTorch, which built on NumPy, more or less. And something like this would come in later. Okay, so that's it for NumPy. Again, there's tons of things that you can do with NumPy. Usually, if I came across something with NumPy, I'm probably gonna show you later on. But let's skip into another thing called Panda. Okay, Panda is my favorite library for data manipulation. It's like the best thing for dealing with tabulated data. So think about Excel. If you have something in Excel, you use Panda, okay? And Panda is very, very useful when if you open your Excel and there are like tons of rows, tons of columns, and you start to get overwhelmed by just navigating through it. And you know, if you want to do some calculation in your Excel and it starts to get slow, that's where Panda shines, okay? So firstly, we're gonna import Panda. So import Panda. Okay? And normally this one would be sufficient, but people are too lazy to type Panda all the time, so we're gonna use the alias called PD. Okay? So when I talk about pandas, it's best to think about it as your Excel sheet. Okay? So let me show you this. If I were to use the similar type of data in my Excel, for this, it would be something like this. Name, age, score. Okay? The first one would be Alice, Bob, and Charlie. You get what I mean, okay? David. Okay, and the age would be 33, 25, 30, 22, something like that. One score. Let me just do this. 85, 90, 88, 95. So that would be the equivalent data in Excel. Okay, this is Excel tabulated data, right? This is the same data. I'm going to convert it into something called the data frame. So this data frame is your kind of go-to object when you want to deal with tabulated data. Okay, so let me just show you first, and I'll explain along the way. So I'm going to use DF, which is stand for data frame. You can use anything, but this one is my convenient name. PD, which is panda dot data frame, okay, with the capital D, and then I'm gonna put in data. That's it. That's all you need to do. So essentially, you're putting data into some, I would say, methods to create the data frame. Okay, and the cool thing about this is that you can just type it df in here, and you're gonna see something that looks very familiar, just like this. Okay. For you, it's probably gonna look different because I use another extension called Text Wrangler. Okay, so if you're curious what I use, it's called Text Wrangler. So this one is particularly useful when you use Panda. Text Wrangler. This way. So if you want, you can install. Why don't I see it? Oh, sorry, Data Wrangler, not Text Wrangler. Okay. So if you want, you can install this extension called Data Wrangler, and this one gonna format your output of your data frame to be even more powerful. So normally it's pretty good enough, but this one gives you more ability to do like filtering, sort, and all kind of things. So super useful. Okay, so I'm addicted to this right now, right? So right away you can see the similarity between this and this one, because exactly what Panda is doing is mimicking your Excel data sheet, basically tabulated data. Okay, but there's a difference in here, right? If you compare what this is and what this is. Okay, first of all, I want you to check this one out. This one, you see that the column has a name called name, age, and score, right? But if you go to Excel, you can see that the name of that column is actually not name, age, or score. It's actually ABC. So in Excel, you are forced, all right, to give it the first row. The first row of your Excel is always going to be the column name, which is kind of annoying, because normally we just want the data to be inside our sheets, right? It would be nice to actually, if you can change ABC into the name of that particular column. But in Excel, you cannot do that. You are fixed with whatever they have. So you have to kind of work around it, because the first row is always going to be the name of the column. But in Panda, you don't have to do that. The name of that particular column is actually name. So you're going to refer to all of this as name. Okay? And this is quite useful, because remember, like if I want to do something with the formula in Excel, I have to do this, right? There you go. All right, +2, right? Ever wonder why it has to be B2? Like I think B2 is very unintuitive, right? Like why can't we just do something like name? Like it would be really nice if you can do name, right? Sorry, age. Right? If I can do something like this, then I think my formula is actually looks, readable, and it's much more understandable than B2, right? And you might think that this is kind of small point, right? But Panda is creating for large data, and if you have let's imagine you have like 100 columns, and you try to do formula like this in Excel, you're gonna have something like AA plus BH plus AC. And it just gets out of hand very easily once your formula starts to be complex. Instead of, why don't you have age +2? Like wherever they are, I don't really care, but I just want age +2. Much more handle. So Panda, that's the core philosophy of that library. Like big data, lots of columns, lots of row. How do we handle it? This is one of the first things that differentiates itself from Excel. So your column is has a name. Might sound small, but it's actually super useful. Okay. All right. So I might get ahead of myself too much, but let's do some basic manipulation of your data. So I want to print the first two rows of the data frame, because usually if you have tons and tons of data, then you probably don't see all of it. Like you don't even want to print it out because it's gonna take too much memory. So let's print it out. So I'm gonna say df. I can say dot again. You have tons and tons of methods that you can use, right? The one that I want is called head. Okay, so again head. Head is to print the last 5 rows, I believe, right? But if you want to print 2 rows, I can do head 2. Right. So again, I can just put in number 2. Okay. If you ever wonder what you should put in, again, you can put your mouse on it and say n. So n is the number of row, right? If you want to do like a input keyword argument, you can do n equal, but nobody do that, right? Because it's too easy. But if you want, you can do n equal if you want, but I'll just do head 2. Okay. Just in addition to head, then you can also have tail, df.tail. Okay. Tail is the opposite of head, so printing the last 2 columns, 2 rows of your data. Okay. Okay. And another thing that I can show you is that let me just show you this. If I want to, do something with my data, like I want to show my data. For example, I want to show the age, right? I can do df, right? And I can do with my age. See? The fact that I can do this is pretty useful already, right? See, when I want to check out the columns that I want, then the name kind of come out right away instead of, I don't know, A2, A3, which doesn't mean anything, right? So I handle my data with the actual name. So I want to see the name of people, then I got the name like this. Okay? I want to see the age of people, then I got the age, something like that. Okay? If I want to see more than one thing, then I can do a list of columns that I want. So name and age. Okay. Okay. And notice that once I do this, it's as somebody else come and read my code, then they should be able to understand what I want, because this one is pretty self-explanatory. Okay, so that's kind of a nice thing about being able to refer to your data by the actual name, rather than just like a symbolic things like ABC, like alphabet things. Okay. All right, I don't have much time, so I'm gonna kind of skip things, and I'll come. We don't use much Panda in this course because usually I will make the data as ready as possible for you. But I want to showcase some of this because it's very useful for me in my career, in my other works. So yeah. So let me do something else. I want to add a new column called pass or fail. Okay, so this one, I can try this in Excel. So I do pass, right? If the score is larger than 90, it's pass, okay? So I'm gonna do equal if, right? This thing is larger than 90, or I want to have pass. Actually, it has to be in the parentheses, right? And if not, I'm going to say failed, right? Okay, so that's, okay, I want to do equal, larger than equal. Okay, so it will be pass, 2 guys pass, 2 guys fail, okay? So yeah, you can do this in Excel, right? I want to do the same thing in Panda, but notice how I write it. So right now, if I look at my formula, again, C2. Doesn't mean anything to me unless you make sure this is correct, right? But in Panda, you can do something like this. Okay, so I'm going to say df called pass. So the new column is going to be equal to df score, right? Larger 90. That's it. I got the new column called pass. Okay? So this is how you manipulate your data. Basically, you want a new column that do something, and this can go as crazy as you can and still manageable. Okay, imagine you have lots of columns, complex calculations. It will not look much more than this. Okay, but in Excel, yeah, I can think it's gonna be. First of all, you have to go back and click at the right column, right? Make sure that you don't misclick it and things. So, much more manageable once your data starts to get large. Okay, and again, I can also do some sorts of calculations on the columns too. If you want to do maybe, let's say you want to find the mean of all the age, right? How do you in Excel? Let's see. I have to go to my data, right? I have to do data analysis. Where is it? Actually, I don't even turn it on, so let me see. I have to go to option, right? To toolbar, no, add in, right? And then analysis 2-pack or something like that, if I remember correctly. Go, yeah, analysis. This one? Yeah, okay, so I have to do data analysis, right? I have to do maybe, I haven't done this too often. What? That should be a descriptive statistics, okay. And then I have to choose my column. Okay, I want this guy, the average of the age, right? I have to choose where I want to output stuff. Okay, I want to output it in here and there. And yeah, wait, what? Choose one statistical points. Yeah, I don't remember. It's something in here. And you do something in here, right? Or you can just do this, right? I want to do, okay, wait, I did, okay, this is the wrong result. So I can do df age dot mean. There you go, done, 25, okay. And maybe I'm a bit overkill in Excel, right? I just realized that maybe I can just do this. Equal average, right? I think I can do that. Average, and then just do that, right? Yeah, I'm a bit overkill, okay? So if you want to find the mean of the columns in Excel, you do, maybe this is not too bad, right? But what if I want to do like all the statistics, like I can just do this df.describe, and you see this one, okay? Actually, I got all the statistics of all the things that I want. So this is kind of the thing that, it's built for data scientists. So all of these things should be highly available to you rather than having to click a lot. Okay, so that's kind of like the flavor of Panda for you. Okay. Okay. So before we go today, I don't think we should go to class the other topic, but I want to show you that once you have Panda in your toolbox, then a lot of the data science, data manipulation become much easier. So I'm going to go back here, okay, and maybe I'll tackle this thing a little bit more. Okay, this, right? So I want to print the average grade, right? So how do I do this in Panda? So first of all, I think I can just do this. So let's say import Panda as PD. Okay. Right away, I can try to see if I can do this. Okay, I want to do df equal pd.dataframe. Okay, let's say if I put in students inside, what happened? Oh, I need to run the first line first. Okay, let me run this one again. Okay, and let's see what my data frames become. See, right away, I got, something that goes into my, I guess, go to rows automatically, right? So the ID and the name, right? But this one is a bit problematic because this one actually might be even better if I can kind of split it out into its own column, right? So usually the first step of building this is going to be the hardest, but once you get all of this into your data frame, it will be much easier, okay? So let me do this, but this one is a bit I guess a bit more involved. Okay, I want to do this. So I want the, okay, so let's, I want to do data equal data array. Okay, first I think I want to loop for I in students, right? Okay, and I want to add some data into it where I want the name, okay, to be, actually I want to change it into student, okay. I want the student, okay, of, I think if I remember it's 1, okay. So the second item in my tuple is going to be the name. I think the first one is ID, okay, so the student 0 is going to be ID. So right now I'm constructing my dictionary so that I can have different columns, right? And this is going to be, I think, math, okay? So student of 2, but then with math, okay? And I want English, it's going to be student of 2 with English, okay? And then I think the last one is called science, okay? So I'm going to do science, okay, student 2 science, okay? And then I want to do data array dot append all of this, okay? So again, this part, it just kind of format the data so that I can load into my Panda data frame. You don't have to concern with this, but I want to show you once I get that data frame, then what's going to happen. So this one is special. I have to do from dict. Okay, this one is kind of a little bit more advanced, but once I do this, I can, wait, actually I have to do data array. There you go. So once I did all of this, then I can have kind of like a Excel sheet that, you know, contain ID, name, and then all of, you know, all the score in the same, I guess same level, okay? And right now, once I did this, it's super easy because I can say that, wait, I want the average, right? So average, okay? Grade, right? Gonna be equal to df of math, right? Plus df of English plus df of science, okay? And the rest are what I want to divide it by 3, okay? And if I were to look at it again, then I have another column that called the average grades, right? That's something like that. So, and if you have any more things that you want to do, like down here, it's a create a tuple of student, of all the students. This is super easy now because I can also do df of student ID, right? I got the ID now, right? And I also got the name. I can bring out all the information I want, and then the average grade if I want, something like that. So I can also go in through all of this and then start creating all the data, the shape of data that I want, okay? And if you want to find and print the student with the highest grades, then I can do that too by saying that I want to do, I guess I want to df dot sort value, okay? I want to sort by average grade, okay? And right now I should have the lowest guy at the front, so I should say ascending to false. And now I have the first guy, which is the highest grade, right? And I want to select the first one. It's going to be dot head 1, okay? Okay. So I went very fast because I know this library already, right? But then I want to show you that when you use Panda, these are the things that's gonna happen. So you're gonna keep changing the operation, and normally you can do everything in one line. Just kind of keep doing it, and then this is how you got, right? And then if you want to extract it value out, then you can do to dict. So, and now you got the dictionary, something like that. So it's super useful for you know, complex operations, and usually just one line, and the code is pretty readable. Okay, although you have to get used to all of this first, so it takes some learning curve. Okay, but keep in mind that I will use this one from time to time, although you probably doesn't use this much in this course. But I use this all the time for data manipulation, things like that. Okay, and again, if you want to do the mean, right? I think this one the map each subject to the whatever. Okay, I don't wanna bore you too much, but okay. I think today that should be it. Next time we can do the class, which is kind of the big topic that I want to go through. So yeah, and I post the homework for you in the Canvas. It's due in 2 weeks, so you have a lot of time. So you can even do it after the midterm. So it's due a day before the next class, which is in February. So take your time. Again, no AI. Please do your best. Okay. Thank you. And then again, see you after the midterm, and from now on, it's gonna be Thursday afternoon. Okay, not evening, not morning anymore. Afternoon from now on. Okay.